Okay, so the first application I developed this summer is what we are looking at right now, and it's the Bangladesh Agroecological zoning application. So this serves a number of functions. We originally created this using R Shiny, which is an application that's integrated into R that allows people to, interact with data through a URL or through an application. But due to bandwidth issues, we decided to switch this over to Google Earth Engine. So I spent a lot of time learning JavaScript and building this app in Google Earth Engine with the help of R Markdown and QGIS. Um, this application does a number of things. The primary function is to show insurance providers where they're currently operating, indicated by red, and where they might want to operate in the future, or where they might want to expand on their insurance provision for different crops in areas where they currently operate. So, say this district, for example, um, say they provide insurance for Boro rice, they might want to expand this to Amman rice as well, or to a different crop like potato, depending on the climatic variables, which can be shown through a number of different visualizations. Um, it would take a long time to walk through all these individually, but I just wanted to give you a sense of what this application looks like and some of the interactions. So a number of different data sets can be displayed both visually in the raster file and more statistically in this pretty rudimentary bar plot that we've created for different variables that are integrated through shapefiles in Google Earth Engine. Right now we have onset date mean and standard deviation, which are pulled from the CHIRPS dataset, which analyzes annual rainfall. And we also have water recurrence, which is pulled from the global surface water dataset, all of which can be found in Google Earth Engine. We pulled this data and did a lot of cleaning to create this visualization. And yeah, the other data sets you're seeing here are actually were given to us from the Bangladeshi government. They've created an application called BDP 2100 that can be found online, and decided and agreed to share the shapefiles with us. So we were able to integrate this as well, which is great because these are some solid visualizations on drought and flood-prone areas that they've been able to collect internally. So these can also be visualized. There's a couple of things I'm not allowed to go over at the moment due to data privacy concerns, but I can just show you what we've also integrated based on farmer survey data. Areas where farmers that our clients have worked with, where they've reported drought hazards and reported flood hazards. So an application for this might be to analyze how, the correlation between where farmers are reporting drought and where satellite data reports drought on a yearly basis, see if these align. And if they don't, maybe there's an issue with the survey design or our outreach, or there's an issue, in some aspect of the reporting. But that's just another example of how this can be utilized. A couple other things we added, a download functionality so that they can display this data in a table format. And we also created a guide in our Markdown that gives a quick tutorial on how to go through this. And then I created legends using QGIS to build what you're seeing here. And we also provided additional information on each one of the data sets that is being integrated into this application so that the users have a bit more information of what they're looking at, so they can pull this up and download it if they want while they're looking at the application.